back in 2009 or 2010, I was just like basic computer scientist working on areas related to wireless sensor networks and quality of service, networking issues, and so on. And I decided to do some project around robotics, but I wanted to do them from the computer science perspective. Things related to multi-robot coordination, so we wanted to design some algorithms for the collaboration between robots and also try to investigate some possible path planning algorithms on how to design some path planners and so on. So being actually a practitioner, I wanted to implement these techniques into robots. And at the same time, I like developing high-level softwares for the applications that I'm targeting, but I don't like actually to program at the low-level drivers, like, for example, developing the hardware or making C drivers for different type of hardware and so on. This is something that we don't like to do as a computer scientist. And it's really enjoyable to work with robots, but there are a lot of complexity in what comes to, for example, the kinematics of the robot, the dynamic models, and everything that from mechanical perspective or electrical engineering perspective. So in the beginning, we were able to implement this algorithm, but it was kind of very basic because we did this at like in a simplistic manner, considering that we didn't have a comprehensive framework like robot operating system. So I'm going to show you how did we start working with robot and how ROS actually have changed all our way on developing software for robots. And probably this is related to my experience, but I think it can be actually generalized to why ROS is really a very important framework for developing robotic software. So during this lecture, I'm going to provide some intuition why ROS is important. I will provide an overview about ROS and ROS2, and then I will talk about the contributions that we have done around ROS, both in terms of education and research. So why robot operating system? Let's consider this is one of the projects that we have been doing back in 2010. We were working on path planning algorithms. This is a nice platform, the Wi-Fi bot robot, but at that time it didn't support ROS. And at that time, ROS is still starting. I mean, maybe it's still version 1 or version 2. It was not that popular as it is today. So we had to implement everything. In this simple application, we just need to hard code everything, the location of the robot, the path that it has to follow. It was kind of manually hard coded. We don't have any kind of sophisticated way to build a map or so on. So this was one of the first prototypes where we tried to implement some kind of path planning algorithm, but at a very simple level. And okay, also in terms of the reactive navigation of the robot. So same thing here, if you want to avoid obstacles without hitting obstacles, so you need to use like sensors like ultrasonic sensors or laser sensors. But if you do this, if you do this manually, it's really a painful way. Usually you have some kind of low-level C API that is very limited. So I remember then when we wanted to make this robot move, we have to send a low-level command to the right, to the motor in the right side and to the motor into the left side. So you need to send the signal. If you want to rotate, you need to send a signal that is higher in the right side as compared to the left side. If you want to move forward, the signal has to be the same. It was kind of really not that easy to develop robotic application because you have to deal with very low-level APIs at the C language level. Also, I remember another project. We wanted to do some kind of collaboration between drones and robots, so we wanted to make a drone fly. And I remember we have taken this Aztec Firefly drone, which is very sophisticated. But programming it was really kind of nightmare. Without using ROS, it has a C++ API that was not really trivial to work with. At least, as I mentioned to you, we have computer science profile, and we would like only to consider on developing at the high level. Okay, we don't want to go into the deeper level, going into the drivers or how. We want something like make things easy. I want the robot to take off. I want just to send take off command. I want the robot to move forward. I need to send just a forward command or some kind of velocity and so on. But these kind of things were not easy in the low-level APIs that were provided by these different robotic platforms. So we found out that there is kind of limitation if we want to bring our models into reality and implement them into robots. Until in 2011, I think I remember, maybe I have heard about ROS in 2011, and when I started to dig about it, I found that it provides really the things that we really need to move forward in terms of the implementation.